Welcome to MongoDB TV. It's Thursday. Generally, you're used to a Cloud Connect series with Shane. I'm taking in for Shane today. I'm Jesse Hall, Senior Developer Advocate, and we have a special treat for you today. We're going to be talking about RAG, Retrieval Augmented Generation in real life, and we're going to walk through step by step how to use the MongoDB Chatbot framework, open source framework. So stick around for that. First of all, I wanted to let you know about MongoDB.local in New York City on May the 2nd. If you're in the New York City area, stop by. We'll be at the Javits Center May the 2nd. Use this coupon code here, Community50, to get 50% off of your registration. Again, May the 2nd. And if you're not available, if you're not in the New York City area, we will be live streaming the keynote, and the rest of the day will be live streaming interviews with some special guests. So check that out as well right here on YouTube and LinkedIn. All right, so many of you may have already completed the Wilco Rag to Riches quest. If you have not, there is a link in the video description or under the LinkedIn event to go to sign up and register for the Rag to Riches quest. It's completely free and it's so cool. I went through it, and you get a certificate of completion. You get some other benefits like 50% off of the MongoDB certificate exam as well, a certification exam. So be sure to check that out. And what we're going to be doing here is basically showing you what to do after this. After you take the quest and you go through this course, how can you actually implement this into a real application and see it in real life? So without further ado, let's bring on our special guest who's going to show us how to do that, Ben Perlmutter. And you are a frequent guest on our show, so many who watch often will already know you. But give us a really quick introduction.
Sure. So I'm Ben. I'm on the educational AI team at MongoDB. We've built the MongoDB Docs chatbot. So if you go to mongodb.com and on the homepage, it's right front and center, and every page, it's down in the bottom right-hand corner. You can chat with our docs using generative AI and retrieval augmented generation. Nice. I'm responsible for that. My team is, and we've also worked on creating the MongoDB chatbot framework, which we'll be looking at today.
Yes, and you could find that here on github.com/mongodb/chatbot. So go ahead and check that out as well. Please give it a star while you're there. We would very much appreciate that. So again, like we talked about, we're gonna find out how can we actually use this open source framework that you can find at this GitHub repo. What would you like to? Let's go ahead and show the demo site, I guess. And we'll show like the end product, and then we'll walk through how we got there. Right?
Sounds good.
All right.
I will share screen.
Awesome. And Ben also wrote an article that kind of outlines how this chatbot was built as well. And so there is a link in below also to that blog article if you want to check that out later on. But go ahead and show us this demo here.
Sure. So before we look at the live chatbot, I just want to touch upon what it is that has been built here.
Yeah.
So the app we're calling the Gilded Age Gourmet. This is a retrieval augmented generation app made with our framework that lets you talk to the Fanny Farmer cookbook. This is a cookbook of classic Americana style recipes from the turn of the 20th century, and useful for our case here. It is fully in the public domain, so we can use the data without any lawyers coming after us.
Nice.
So yeah, important.
Yes.
So let's take a look at the demo. So we have created this little website that we can use for our chatbot. Jesse, do you have anything that you'd like to ask the Gilded Age Gourmet?
So I think this is pretty Americana, and I would say it's like my favorite dish. So like how to make the best meatloaf.
let's see.
Let's see. What does it say? Nice. So it
So it
gives you,
seems that it's not
yeah.
in the cookbook, but
Oh,
we are still getting a recipe, I guess, somewhere in the weights of the large language model, which we're using,
uh-huh,
which is ChatGPT GPT-4 Turbo.
uh-huh.
They know how to make meatloaf.
So yeah, I was looking to see what it would do, and I see it says ketchup in there, and I was thinking in the 1800s, did they have ketchup? So
Yeah, maybe meatloaf is a more modern invention,
maybe it
something.
is.
But
Maybe it is. Yeah, I have to look at
I
the
know we
history
have
of
some
meatloaf
lobster
after
stuff
this.
though.
Okay.
So let's try
Well,
that out.
nice. Oh, and okay, so it actually gives you also, I saw above, references to portions of the book that it pulled from.
Yep.
Nice. Related resources. Nice.
Hmm.
Okay. And so did it find an actual recipe from the book
I believe
or?
so.
Yeah, okay. Okay.
So we have our recipe and then the related resources, which it
Mhm.
found using retrieval augmented generation to help generate that answer.
Yeah. So that's the key here is the chatbot might know how to make this lobster bisque, but the book itself is adding extra information, extra context. And so we're pulling from that
Hmm.
extra context in this generation, which is the key. Awesome.
Hmm.
Okay.
So this
Uh,
is what we'll be building. Perhaps now we can take a quick look at how we build it.
yes. Yes. How did we get here? Do you want to maybe just show the chatbot GitHub page again, and just to kind of set the basis, like this entire framework is built off of the open source chatbot framework that you and your team helped to build.
Yep.
Okay.
So here is the repository for the chatbot framework. You can poke around in here and you'll also see our implementation of it, which you find on the MongoDB docs website. So you have the source code for a full running production retrieval augmented generation application that uses the framework in here.
Nice. Nice. And what is this framework built on? Like, what are the key pieces?
Yeah, so we really leverage the whole MongoDB developer data platform to create it. Specifically for retrieval augmented generation, we use Atlas Vector Search. So that lets you do semantic search over text or, well, in our case, text, but you could do it over
Mhm.
any form of data that you generate vector embeddings for. And we also use various other MongoDB platform features for the rest of the application. For example, we store our conversation data in MongoDB as well. And the way
Mhm.
that that looks in practice, we can look at it in Compass.
Yeah. So
So
you like store the
we,
history of the conversation for extra context, even.
yep,
Yeah.
yeah.
Nice.
So whenever you put a message in, it is persisted to MongoDB, and we have that right next to our vector embeddings indexed with Atlas Vector Search. So just a separate collection in the same database. And having
Nice.
it all centralized in one place really makes things easier to work with.
Exactly. That's one of the main benefits, having your operational data next to your vector data all in the same place. Much you don't
Hmm.
there's no CI/CD involved, having to make sure everything's in sync and etc. So that's really nice.
Yeah. And being able
Nice.
to use like the MongoDB query language to query the data is
Uh-huh.
quite nice as well. And this is even when it doesn't have to do with AI. Like if I want to, I don't know, see the average token count
Mhm.
for the embedded content. Actually, I don't know how to do that offhand, but I
Mhm.
bet this AI does. So we can be
If you
like,
if you could command plus maybe a couple of times there, and this is a really
yep.
cool thing that we're going to be showing off a little bit more at .local NYC is this generative AI capabilities that we are adding to a lot of our tools as well. So this is directly inside of our tool Compass. What is the average token count for the documents in this collection? And so this is going to help you generate the MongoDB query to answer this question.
So this created an aggregation,
Nice.
and we have this pipeline, and let's see. So the average token count is 860 tokens per chunk.
Wow. So you didn't even have to you didn't know how to create this aggregation. You asked it a question and just created the aggregation pipeline for you.
Yeah. Yeah, this
Nice.
is really, really useful for these little bespoke things like this. You don't need to, go to the documentation, dig in, that type of thing, or even go to ChatGPT. You can just do it right next to your data.
Nice. Nice. That's amazing.
Yeah,
So
this feature is great.
yeah. Yeah, again, we'll be previewing more things like this and new announcements on May the 2nd. So be sure to check that out. So back to the framework, the chatbot framework.
Mhm.
What what technology or what language and technologies are this based off of? Like the base of it, I believe, is Node.js, right?
Mhm.
And also on the front end uses React. And then
Yep.
what type of AI technologies, what models can be used with it as well?
Yeah. So we built the framework to be incredibly pluggable. We didn't want to lock in our users or ourselves, because we are
Mhm.
also users, to any specific model or provider. So we, in our production instance, are using the Azure OpenAI service with GPT 3.5 as our large language model. But as noted before, we're using GPT-4 Turbo in our demo here. And you can also plug in pretty much any model.
Nice.
We support LangChain. Anything that LangChain supports, we support out of the
Mhm.
box
Mhm.
because we have a first-class LangChain integration. But
You
you
do.
could also create your own interface and bring your own model.
Nice. Very adaptable there.
Yeah.
Um, okay, so go back to that slide you were at just before there. The four different features of the framework. We've got the server, the UI, the CLI, or the ingest and the evaluation. Just briefly hit on these four things.
Sure. So the server, this is where I would say the meat of the logic happens. This is a wrapper around Express.js that lets you manage your conversations between the user in the browser and a large language model, plus persistence to MongoDB, and also any retrieval augmented generation logic.
Hmm.
Then we have our UI, which is some React components that you can easily plug into your website and get talking to your server.
Nice.
Next, we have our data ingestion CLI that helps you pull data from a data source. And our data source interface is incredibly pluggable. So you can also pull data really from anywhere that text can be represented and called with an async function and
Hmm.
pull it into MongoDB and do that efficiently and taking into account things like chunking, adding metadata, make it pretty easy.
Nice.
Then most recently, we added an evaluation CLI, and this is a module that helps you evaluate how your chatbot is performing qualitatively speaking.
Hmm.
So, like, are the answers correct? Are they good? Are they long, short? That type of thing. And this is really important once you've built your initial prototype or even like shipped an initial version to production. Once that is done, you want to be able to iteratively make changes on it and make changes with confidence and say, make things, I don't know, 3% better. That's really, really hard to test manually, but you can quantify it using some tools in our evaluation CLI. So you can feel confident that you're making incremental changes, and you make a few 3% improvements that really adds up to something substantive.
Yeah,
And that you
nice.
iterate on your application.
Exactly. Awesome. So for specific tools in this one open source framework, and that seems very versatile as well. So Leah, let's jump into some code, and let's go back to the repo and show them how to clone and get going, and then and move on from there. And then
Sounds
again,
good.
that repo is here, GitHub/MongoDB/chatbot. And while you're there, be sure to click that start button.
So this is actually a different repo with our demo code.
Yeah.
This is
that is this one. Which one is it? Hang on. It is it this one? Yeah, there we go.
there you go.
MongoDB-University/cookbook chat. If you want to follow along with the demo, that's the repo that you would clone.
Yep. So this repo uses the NPM packages that we were just looking at to create the chatbot, which we also just saw.
Nice.
So I already have it cloned on my local machine. Would you like me to clone it again, or should we just jump into the code?
No, yeah, let's jump into it. Yeah, so this is the repo. If anyone wants to follow along, again, you can clone this locally. Ben's already got it done, so yeah, we'll move on from there.
Okay. So we are in the repo, and we are looking at the code here. In order to get it set up, you should fill in this environment file. I already have it done on my machine, but you just need to add your MongoDB connection URI, and then go to OpenAI's developer platform, where you can find an OpenAI API key.
Awesome. If you don't mind, maybe Command plus once, maybe twice, just for the viewers. Some of our viewers are actually watching on mobile devices, and so we want to make sure everybody can read what's going on here. So yeah, make sure you get your connection string, your OpenAI API key, get the environment variables, and rename that environment variable file as well. Take the .example off of it. And then you should be good to go after that. Don't show your actual one.
No.
Okay.
So we have our environment set up. And now that we've done that, we can proceed to ingest the data. So I have included the data in the repository. I found a HTML version of this cookbook online, and then I just scraped it down and converted it into Markdown, which you can see here. So baked halibut with lobster sauce, one recipe in there, for example. Yum, nice. I guess.
Yeah, sounds amazing.
Yeah. So now that we have our data, we want to ingest it so that we can chat with it. And by ingest, I mean pull it from this Markdown form into MongoDB Atlas in a collection indexed with Atlas Vector Search, plus create the embeddings for it.
Nice.
So as mentioned, we have our ingest CLI to do that, and I have this package here, which uses that CLI.
Amazing. I also want to tell the audience, if you have any questions along the way, please comment or if you're on YouTube, chat with us. Let us know if you have any questions, and we'll also leave some time at the end for questions as well. So, all right. So this is the ingest config.
So you can manage all of your data ingestion from this one configuration file.
Okay.
In here, you define things like what embedding model are you using to create the vector embeddings for your content. Also, where it is that you're storing the data, how you're going to chunk it. So these files that we were just looking at, that markdown is quite large. So you want to break it up into smaller chunks to work better with the large language model and the vector embedding model. So you can define the strategy for that here.
So that chunk size of 1,000, what is that definition of 1,000?
So this is 1,000 tokens using the OpenAI GPT-3 tokenizer.
Okay.
Roughly one token is like 2/3 of a word. So like a big word might be broken up into a few tokens.
Okay. Okay. That's good to know.
Yeah. And you can define custom strategies as well for your tokenizer.
Okay.
So like if you're using a different language model, you can define a different tokenizer that will define your chunking strategy here.
Got it. Okay. Also,
And
everything
lastly,
is in TypeScript. Sorry, everything's in TypeScript. So you've got all of the hints and everything else there to help you with what's
yes.
available, which I love that. Yeah.
And then lastly, we define our data sources. So in our case, we have this cookbook data source, and we are using we call it the make markdown on GitHub data source. So if you have markdown files that are living on GitHub, you can use this constructor. We also have a few others that you can employ in addition to supporting LangChain data sources. So
Nice.
if LangChain supports it, we do too here.
Nice.
So now that we have seen the data that we are ingesting and how to ingest it, we're going to actually run the ingestion, which is very straightforward. Once you've added the ingest package, you just need to run the command ingest all. So we can do that now.
Okay, so this is taking those markdown files, chunking them, splitting them up, sending them to OpenAI, getting those vector embeddings, and then saving all of that to the MongoDB database, basically.
So this is creating the vector embeddings right now by calling that OpenAI API. And this will take, I'd estimate, like a minute. So rather than watching my terminal, let's look at how we can create the Atlas vector search index.
Perfect. Yes, let's do that.
So we are adding this data to MongoDB. You can actually see it here in Compass. If I refresh, so we've created this new database, cookbook dev. And right now it has 102 documents. If I refresh, there's 125 because we're continuing the ingestion.
Yeah.
But right now, this is just like a standard MongoDB collection. We need to add Atlas vector search to it.
Got it.
So let's do that in the Atlas UI. And we can do that in the Atlas search tab.
If you don't mind,
create a new search index.
Command plus like 2 or 3 times. Yeah. Maybe one more time.
One more.
Yeah. I usually tell guests when you feel a little uncomfortable on your side, it's like huge. That's perfect.
Great. So we are now in the create a search index screen. We're going to create a vector search index using the JSON editor. We're going to do that on the embedded content collection in cookbook dev.
Got it.
I actually do not remember offhand what the index is, but that is okay because we are using the same configuration as exists in the quick start. to the framework, which you can find in the framework documentation.
Mhm.
And it is here. Just copy that and bring that over to the Atlas UI. And I will
Nice.
make that uncomfortably big now.
There you go.
So yes, you can see that here.
Perfect.
And we'll just paste that in.
Got it. So we're defining the definition there. Dimensions 1536. That's the standard for ChatGPT 3.5 and 4. Or this is actually not 3.5. This is how the model you use to create the embeddings. Let's talk about that really quick. Which model was used to create these embeddings?
Yep, we use the OpenAI Ada 2 model.
Nice. And that uses 1536 dimensions.
Yep, all the
Nice.
embeddings
Okay.
are of length 1536.
Yep. Nice.
So this is just a confirmation screen. Yes, let's create the search index.
Yeah.
Building in progress. This
And
will
that
probably
generally
take
takes like,
about 30 seconds, a
yeah, I was going to
minute.
say 30 seconds. Yep. Usually pretty quick. I mean, it depends on the size of your collection, obviously. This one probably 30 to 60 seconds. Shouldn't be more than that.
Yeah. And if I were to add more data to the collection, the index would update dynamically as well.
Nice.
We're not started yet, but it will be there in a moment, I think.
Yeah, for sure. Now, if we tried
And
to
while
run
we're
a search before the index, it would fail. So just give it that few extra seconds. Make sure that the index is completed before running any searches. But we should be good by the time we get there.
it's good now.
There, yeah, that was quick.
Yeah. So now that we have the index made, we can query it using our server and UI.
Got it. So now,
So the
we
whole
we
server.
use the ingest package. Now we're going over to the server package, and get that up and going. Okay, nice.
So this is all configured in one file. Also following closely the quick start in the documentation.
Okay.
We do things like define what is the large language model, which we are using. In our case, it's GPT-4 Turbo.
Got it.
And then for retrieval augmented generation, we're defining where it is that we're getting the embeddings and the related content from, how we are embedding the queries to find matches with that content using the same embedding model, and then how we pull it all together to answer user's question. We pull in that context information plus the original user message to generate the user message. We also have our system prompt. So this is what gives the chatbot its personality. I was answering in that kind of funny early 1900 style. You can see that here. It's just like 100 words of text. So this could
Yeah.
definitely be optimized further.
Sure. This is the part where prompt engineering comes in.
Yep.
Nice.
So we define that here. We also define where in MongoDB we're storing our conversations. Bit of boilerplate to start the server as well. And yeah, that's all.
Awesome. We have a question really quick. What are you developing? So we are in the middle of creating a RAG chatbot application using MongoDB and our open source chatbot framework, which you can find here. Again, give it a star if you go to this repo, check it out. But yes, we're at the server. We're about to get the server going. So we're about halfway done.
A bit more, I would say.
Okay.
Because the rest
Rest is
quick.
pretty simple. Yeah.
Yeah. Honestly, the data ingestion part for demoing purposes is the most time intensive.
Got it.
But then when you got everything up and running, you can play around with the server a lot to optimize it for your use case.
Interesting. Okay.
And also I want to touch on the UI because it's real quick. So in order to talk to the server, we do it through UI. And we have a couple of React components, which you can see here.
Okay.
and that's the MongoDB Chatbot UI package. So we have this package, and you just add these components to your React app, and then that gets you up and running, talking to the chatbot.
Nice. Super easy.
So now
I love that it's using Vite as well. It looks like it's using Vite.
It is using Vite.
Nice.
Yes. Shout out to my teammate Nick for setting that up.
Awesome. Appreciate that. I'm a big fan of Vite.
Me too, in my very limited exposure to it. It's what Create React app was a few years ago, but yes, even better.
It is the better version of Create React app for sure, in my opinion.
So we, with that command, are running now the UI, and that's running on localhost 5173, and communicating with our server, which is running on localhost 3000.
Wait, go back really quick, because I think I blanked out for a second. What command did you just run? You can go back up.
Oh yes. So let's make that bigger as well.
Yeah, a little bit, maybe. Yeah, 2 or 3 times. Again, whenever you're uncomfortable, it's perfect. Perfect. That's good. I'm a little uncomfortable now. It's all good.
All so right.
npm
the command
run dev.
is just npm run dev, and from the root of the repository that runs both the UI and the server.
Got it. Perfect. So that spins up the server and the UI. So the server is running on 5173.
That is the UI.
The UI. Okay. The server is running on 3000. Okay. Got it. Nice. So this is the application that we demoed at the very beginning. Now it's running locally. You ingested the data. It's a clone. It's a separate version running the same data basically, but now locally on your computer. Awesome.
So do we have any questions we want to ask the local version? Make sure it's working.
Let's see. Let's see. Questions. Let's see. We did fish. What was popular back then? I mean, I feel like something with potatoes is like a potato au gratin. How do you even spell that? But
potato. Even if we don't know, I think the LLM will.
Yeah, even if you misspell it, for sure. Okay, there's a question here. Are you using concurrently to run both the client and server together? What do we use? No, I think it's just a script, right? It's just spinning them both up.
Yeah. We can look at what I did specifically there, because I don't remember offhand, but we don't use any package in particular.
Yeah. I don't think it's concurrently. I think it's just a script combining the two commands to get those running. All right, so what do we get?
We got potatoes au gratin.
Nice.
A dish that sings of comfort and sophistication.
Interesting. All right, thinly sliced. Okay, yeah. Sounds right. And it looks like it pulled from potatoes and eggs from those chapters. Okay. Interesting. So it's working locally. That was fairly easy to get going, honestly. The package really helps out with all of the intricacies, so that you don't have to write a lot of boilerplate code on your own.
Yeah, that's really the goal of it, and to provide you with like not just the boilerplate, but the places to plug in your custom logic. Because given the whole novelty of retrieval augmented generation and generative AI application development, it can be quite overwhelming to even like think about where do I start, where do I optimize, let alone how to take it to production. So we try to give you like, say, 10 or so places that you can plug in and customize to really optimize it for your use case while taking care of the boilerplate that's sort of universally applicable.
Got it. Yep. That's That's amazing. And so what could we do from here? Like we've got it going, we've got the basics ingested. Maybe we can look at tweaking some things, or like how to optimize certain things. Maybe we can take a look at that.
Hmm. Sure. So I think going into the server is a great place to start.
Okay. So
And
and
maybe
then I
we
mean,
can,
even going, like, we don't have to go back to this point, but even during the point of ingestion, that's kind of where thinking about chunking strategy would be a thing as well. But then on the server side, there's other things that we can tweak as
yep.
well.
So
Mhm.
on the data ingest side, maybe you would want to set chunk size to 500, see if
Mhm.
that gets you some more precision, or if you want to add some additional metadata to your chunks, you could add that here, change your tokenization algorithm.
Mhm. What about like overlapping, like where you include a little bit from the previous and next chunk? Is that a thing as well? There you
Yeah.
go.
So
Overlap.
say
Add a little
100.
extra
Right now,
context.
overlap is
Mhm.
0 by default,
Gotcha.
but we
Got it.
could update that.
Yeah. So it depends again on the content that you have and how you can play around with these numbers. There's no exact science to this. It's kind of a matter of trial and error, depending on
Okay.
your use case, and you can kind of dial things in there with those different options.
Hmm.
Awesome. And then yeah, let's go over to the server side. What options do we have here on the server side to dial things in?
So playing around with the system prompt is a great place to start. I
So,
mean, we could like have it talk like a pirate or something absurd, or perhaps I noticed the answers are a little long.
uh-huh.
We could have the LLM shorten them.
Yeah.
Do
I
you have
like the word
any
concise.
thoughts?
I always tell ChatGPT, be concise in your answers. Oh, you did already, but it's already long. Hmm.
Yeah.
Interesting. Yeah, prompt engineering is definitely a thing. Play around with that, and should be as short as possible. Yeah. Yeah, I love you. You must have Copilot or something trying to give you suggestions as well.
Yeah.
Nice.
AI
Um,
everywhere.
here's a question that just came in. Again, audience, if you have questions along the way, feel free to ask. This is great. What if the data is in the database already in the collections? So the data that you are trying to um, vectorize, if it's already in the database, what do we do?
Sure. So to use the framework as you see it here, you would need to put the data in this format, this embedded content format, but you don't strictly have to do that. You would just need to create a different, one moment, embedded content store interface that talks to the data as it's structured in your database.
Mhm. So technically, you
So
could take that. Let's say you already have data in a collection, and let's say there's some text field in that collection that you want to vectorize. Technically, you could just add another field to that document, to each of those documents that contains those embeddings, and then alter this structure here to then query that. Would that work?
yeah, you could alter your documents as well. Um, the way that the server works is it just uses an interface in TypeScript, and in
Mhm.
our case, the implementation of that interface talks to MongoDB following our specific collection format. So you could adapt your collection to follow this format, create a new implementation that talks to your collection. Honestly, you could even use a different vector store and it would still work here.
Mhm.
We don't recommend that, of course, but
Wait,
it's very
let's just say you
flexible.
can't.
Yeah.
It's flexible. Okay, we'll keep it at we'll leave it at that. It's flexible. Yeah. So the options are alter the interface to match your collection structure, or create a collection structure that matches what we have here. Yeah. So either
Yep.
way, it's definitely doable. It's flexible. Just requires a little bit of tweaking. Nice. All right. Let's see, where were we at? Okay, on the server side, we were talking about prompt engineering. What else can we do in here?
So another useful thing in affecting the output is changing the temperature.
Mhm.
So perhaps you want it to be more consistent in how it answers, less creative.
Mhm.
You'd set temperature to 0. So if you're doing, say, chat with technical documentation, you don't want it to be creative. You would definitely want to do temperature 0. Like in our docs chatbot, that's what we do.
Mhm.
But
Yep.
if you were doing like some creative writing
Mhm.
application, maybe you'd want to set that higher to like 0.8.
Mhm. Yeah. And you have to kind of be careful with that as well, as if you set it too high, it can be so creative that it's just inaccurate, right? It'll
Right.
definitely hallucinate more the higher the temperature is, or the chances of hallucination are higher anyway.
Yep.
Yeah. Nice. Here's another question that came in. For each new input chat message, are we generating the embeddings and putting those into the database so that each next chat could vector search on the chat history as well?
Yes. I believe in our implementation, we are not persisting the vectors.
Okay.
Let me verify that though. Yeah, we are not. However, you can, and I
Mhm.
can just show you how you would do that. Um, let's see.
That is a part of the framework. It's just not part of this specific demo,
Yes,
right? Hmm.
I'll put.
Um,
Yeah.
nice.
So there's this embedding field which
Okay.
you can add.
Okay. Just a matter of adding that extra field, and then it will persist the history and use that for context going forward. Correct.
Hmm.
Yeah.
And we do
Awesome.
some of that in our production instance as well to
Mm-hmm.
like track what are frequently asked questions. We'll cluster those. We
Mm-hmm.
haven't included that in the framework, but it's in our repository, our implementation. So you can use that for reference as well.
Nice, nice. Another question came in. Llama index question mark. I think the answer is yes.
Yeah.
We're not
And
using llama index in this demo, but it can be used. Yes.
yes, Llama index TS, we have not defined an interface for it that's included in the framework.
Okay.
However, you could add your own. If we were to go over here, so chat with an LLM,
Mm-hmm.
we have this LangChain one.
Mm-hmm.
So
So,
this gives you access to anything that LangChain supports.
yep.
We don't have Llama index yet, but one, you can create an issue on the repository if that's something you'd like to see, and we can look into that. Or two, you could just make it yourself. Creating a LangChain, this LangChain wrapper took all of like an hour to do. So I can't imagine doing a Llama index one would be too difficult either.
Nice. Yeah. So that's, again, we have since we have a first class, um, uh, what do you call it? Repository, or not a repository, but a project with LangChain. Uh, Anything that LangChain can do, we can just pull that in to this as well. So,
Mm-hmm.
nice. Okay, so let's see. I don't see any other questions here. So we talked about the chunking strategy, the prompt engineering, the temperature, uh, saving history. What anything that we missed?
I don't think so. We covered all of the main components, I believe.
Mhm. And the actual implementation of this demo probably could be done in like less than 20 minutes. You know,
Yeah.
we took a little bit longer here to explain things. Hopefully, we've answered everyone's questions. If you have any other questions, now is the time. I think we're pretty close to done. Any last things that you wanted to bring up, Ben?
So I would say just once again, check out our repository, which contains our implementation. In addition to this documentation website, we tried to be pretty thorough with documenting the framework.
Mhm.
And if you have any questions or run into any issues, please feel free to leave an issue on the repository, and we will try to respond to you promptly.
Nice. That's awesome. And again, this is the basis for the Wilco quest, the Rag to Riches quest. There is a link below. If you have not taken that, it's completely free. And it walks you through creating a basic RAG application, again, using this framework in the back end. And what we demonstrated today is how to take this framework and include it in your application. And it's very easy to use. So really appreciate you showing us and walking through all of that, Ben. I think that is going to be all for today. I don't see any other questions. So with that, thank you again, Ben, and we'll see everyone again very soon, and hopefully in New York City on May the 2nd.
I'll be there.
Awesome. Can't wait. All right. Thanks,
Great.
everyone.
Thank you so
Bye.
much, Jesse.
Mhm.